In this video, we're gonna talk about some ordinary, reasonably priced tools that we could use to calculate or measure the three fundamental quantities in physics. So three quantities, as we mentioned earlier, is length, mass, and time. Okay, so let's begin with the length. So here is a caliper. So this is like a $25 or something like that tool that you could see in a high school physics or college physics lab. Now this one you could use to measure, let's say, the length of this sticky notepad. Right there, you can see whatever, is the dimensions of this. If you have like complicated shapes like these, so to know the, measure the diameter. Okay, to measure the diameter, you can get that number as well, using these calipers. But we don't need that. We don't need that amount of precision to run some experiment. We could use just a regular ruler. Just a regular ruler here. So if you want to know, the size of it, then I can just put it there and I can see. Now, of course, the caliper was much more precise, but you can see right there is about 76 millimeters, and then whatever the decimals after that, it's okay. If we getting within 1 millimeter, that's pretty good. Okay, as far as running some physics experiment at home is concerned. So that takes care of length. Just this ruler, like $1 or $2, you can get it, and that will work for us. Now the next up is time. Okay, now for the time, everybody uses cell phones, right? So you can just use a app on your cell phone. And this one is a really old school type of cell phone. This is before the invention of the smartphones. But anyway, so this one, does a pretty good job. So there is an app on this one. It says stopwatch right there, and then you can see. So it has hours, minutes, seconds, and then a hundredth of a second, up to which we can calculate. So just say start. Oops. All right, so just say start. So it will begin, and then whenever we want to stop, okay. So you can see it gives us up to 1/10 of a second, a hundredth of a second. Now your regular $100 cell phone, whatever it is, it probably give you the same amount of precision, right? So that will also take care of time. So it's just a app, then ruler for the length, and the third item is mass. So in physics, lab, you would see hangers like these. So this is a 50-gram mass that comes with a hanger. So you can attach and then run your physics experiment. But if there is some, odd-shaped item, then you can use a weighing scale. Now the weighing scale, this one is a food prep kitchen weighing scale, so which you can measure up to, I think, a pound or something. And on this weighing scale, so I'm going to turn it on, but it's going to have a blue glow, so pardon for that. As you can see, this one is going to give me about the 1/10 of a gram. Okay, so sorry about the light again, but if you can probably see, it gives me a 1/10 of a gram. This one you can buy like $10 online, and then this is supposed to be 50. Let's see. All right, so 49.5. So this one I believe has a 1/2 gram of precision. So beyond that, it doesn't show 1 gram increments actually, so 1/2 gram. So which is again, within 1/2 gram, it's pretty good, it's pretty decent. But if you want to make your physics experiment a little bit more fun, what you could use is a spring. So this spring here, you can buy it for less than $5. Okay, and this spring, if you attach mass to it, so it's going to get stretched, and then the amount of stretching is related to the mass attached. Okay, not only that, but if you want to get a little bit more precision than that, what you could do is you can use what is called as a periodic motion, or more precisely, simple harmonic motion. Okay, so in the next video, let's see how we could use a spring to measure mass. In this video, we are gonna use a spring to measure the mass of an object. Okay. Now this spring here, you can buy it like $3-4, something like that, something like a hardware store, or even online. And the basic idea is to use something like a hook. This is S hook, or you could use one of those twisted, which you put on the wall, something like that. Any hook is fine. So idea is, so we can have a hook here, okay, and then put the spring, and then measure the length with which it gets stretched. Now, which is okay, and it's actually related to the Hooke's law, but there is another concept, which is if you pull it down and let go, and then you can time it for, let's say, 10 oscillation. Now, what is an oscillation? So oscillation here is from bottom to the top and back to the bottom. So if we are measuring, okay, so let's see quickly how we can set this up. What I'm gonna do is get a tape here, a piece of tape, try to put it here, stick it. Now the tape may not be able to hold it, and which is fine. Right now all we need is just a position. And then on top of that, you can put your notebook or something. Okay, or you can put your physics textbook if you have it, or some other textbook. And then so that this is now it's reasonably firm here. Okay, not too much mass, right? I mean, this here is I'm pushing more than what is what could be required, but for a reasonable amount of mass, this is fine. So put that over there. I'm gonna make sure that the spring stays at that spot, because I don't want it to be swinging back and forth, or sort of stay firm at that position, because I don't want any oscillations of the spring, or the way it goes back and forth, somewhere like that, to affect the measurement here. So I can put this, okay, put it there, all right, and then I could time it. Now again, we may not have this mass, right? So what we could do is we can buy like a ball bearing here, so you can get it from a hardware store, okay, and then use the same tape, all right, and put the bearing here, okay, the steel ball, and attach it to the end of it. There we go. I can see that this one right here is attached to that spring. So again, we can time it. So I got my old school cell phone here, and I'm gonna use its stopwatch from there. So I'm gonna pull it down and then release and start at the same time, and then I'm gonna count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so you can see now I got about 9.28 seconds. Okay, so hard to see here, but yeah, 9.28 seconds. So divide this by 10, and that will give you the time it takes for one oscillation. And in the next video, I'm going to show you how we could use that to calculate the either the mass or the spring constant of this spring. Okay. Here we can see the equation that we can use to measure mass using spring. In this equation, the pieces are T is the period, which is time for one oscillation. M is the attached mass, kilograms. The unit for period is seconds, and the little k is the spring constant. Now when you buy a spring, it comes with a the number attached, with that spring, so the spring constant of it, which usually is in newtons per meter. So the spring that you saw earlier was approximately, 3.3 newtons per meters. Okay. So if you have this quantity right here, and if you have this quantity right here, and if we are trying to measure the mass, then, just a little bit of algebra here. What I would do, step number 1, is to, square both sides. So I would get t square equals to 4 pi square times mass divided by the spring constant. And now we want the mass to be standing alone, so I would move the 4 pi square and k to the left. Now 4 pi square is multiplied, so it gets divided by, and then k is divided by, gets multiplied. So reorganized equation looks like this: t square times k divided by 4 pi square. This is going to be equals to the mass. Okay. Now remember, if you know the time, if you know the spring constant, then plugging into this equation will give you the mass, but the mass is going to be in kilograms. Okay. So if there is a need to change it to convert it to grams, just multiply it by 1,000. So that will give you the number. On the other hand, if you know the mass, and if you want to calculate the spring constant, okay, then in the second scenario, okay, again, square both sides, right? So t square equals to 4 pi square m divided by k. So again, we are saying that we know the period and we know the mass, but we don't know the spring constant. Then you just switch the k and t square. Okay. So what you would get is k equals to 4 pi square m divided by t square. So again, depending on what situation you are in, you could use this equation to calculate one or the other. Now this might seem like a little bit too much, just to calculate mass. You could buy a weighing scale for $10. If you want to do that, that's fine. Okay. But if you wanna, again, with the weighing scale that we saw earlier, it gave us a half a gram, certainty, right? So with this one here, you could get probably within the same range as well. Okay. But again, this is another way of working, or measuring the mass. So we saw earlier that how we could use a cell phone app to measure time, a ruler to measure length, and a spring and a mass, or a weighing scale to measure the mass of the system. Okay, so length, mass, and time. Okay, these three quantities, if we can measure, we can measure using household items, and then we can practically run nearly every single experiment in the part 1, or the experiments that would concern the Newtonian mechanics.